For this video, let's evaluate the limit of a complex function z+1 as z approaches to 2 minus 3i. Before we start with this, of course, we'll be applying here the limit theorems for complex function. And we know that our function is complex because it has our z, representation for complex numbers. At the same time, you would also notice that the value where z is approaching to is also expressed as a complex number. Unlike the value for z sub zeros, that's our z sub 0, right? Unlike the previous examples, especially in proving limits, where we only use an exact real number, this time we have here a complex number in that case. Of course, you could always try to use substitution. That's one technique where you can simply substitute that value here, okay? And then you will get the value of the limit. But let us also try to provide here the process using the limit theorems that we were able to talk about in the previous video. Okay, there's nothing wrong in substituting the value of our z. It's the value of your z sub 0 for your z. But allow me to use the limit theorems previously discussed. Of course, we have here the limit of your complex function z+1 as z approaches 2 minus 3i. Using the first limit theorem on addition rather, this is just equivalent to the limit of your z as z approaches 2 minus 3i plus the limit of your constant 1 as z approaches 2 minus 3i. Okay? So that's the application of the limit theorem we have previously discussed. Of course, from this limit of our variable, okay, we only have here the value of 2 minus 3i. And the limit of a constant, just like the limit theorem for real numbers or the functions containing real numbers, and even for complex functions, is just the constant itself. So we'll have here 2 minus 3i plus 1, which could be written as a 3 minus 3i. This is the limit or the value of the limit of the complex function z+1 as z approaches 2 minus 3i. Now, I mentioned earlier, there's nothing wrong in using direct substitution as long as you are guaranteed to have the value of the limit from the left and the right to be equal. Okay, so this time here, let's just simply try to substitute this if we can. So we will have here, I'm gonna rewrite here the limit of your z+1 as z approaches, approaches 2 minus 3i. By direct substitution, you will have here 2 minus 3i plus 1. That's for our function, which again would result to the same value, which is 2 minus 3i plus 1 or 3 plus 3i. Take note, we write it this manner because that's how we write complex numbers. So basically, we have the same result using limit theorems or direct substitution. Okay, just make sure that you are using the correct operations in order for us to guarantee that your answer is correct. Thank you very much for watching.